Good morning.
Good morning. I think that was really well timed. I was waiting for my recording software to boot up, and right as it came up. Good job. So what's today? The 11th, yes? All right, this is first period. We are the 11th of February 2019, and we're starting with rational functions. The first thing that you see is our f of x, showing that this is likely some sort of function. And then we have a bunch of letters and craziness and weirdness. So let's digest this. This a, it's the same a that we've seen all year. So it's going to control your vertical stretch and vertical compress. It's going to control your reflect in the x-axis. The next thing we see is a b down here. That's going to control your horizontal stretch and compress and reflect in y-axis. We've got this minus c. Whoops, wrong color. What do you think that's controlling?
The horizontal position.
The horizontal position, the horizontal left or right movement. Sorry, I put it in the wrong color. And then at the very end, the d, that is controlling
Vertical.
the vertical position, the up or down translation. All right, you guys are really good at reading this. Let's get into our new function. F of x equals 1 divided by x. So we're going to get a bunch of crazy fractions. Welcome to fraction day. All right, let's start with, I think, the easiest value of x, which is going to be down here. So I'm going to replace x with a 1. 1 over 1 is? 1, and so there we go. All right, let's do the bottom one, 1 over 2. 1 over 2 is?
0.5.
0.5. You're welcome to convert these into decimals. So if you have a 4-function calculator app on your phone, I recommend you use that right now. We want to explore the graph, so I don't want you to go to the graphing calculators immediately, okay? Because we want to try to figure out what this graph looks like on our own. All right, 1 over 4. Do y'all know the decimal for that one?
0.25.
0.25? Okay. Or you can leave them as the fractions, whatever is easiest for you to think through the graphing. All right, let's do 1 over 0.5. I need another sheet of paper for this so I can make my writing big. Okay. So I'm going to do x equals 0.5. That's going to give us a y of 1 over 0.5, which admittedly is really hard to think through. So here's how I want you to convert this. This number at the bottom, the 0.05, that's the fraction 1/2. And so I want you to rewrite it as this weird fraction. Because dealing with what are called compound fractions, fractions instead of fractions, is actually really simple. Here's what I need you to do for these. Take the top value and write it right here by itself. Change this division into a multiplication. And then take this fraction in the bottom and write it as its reciprocal. Okay? Ask a question on this.
So then you would put 1 over 1 and multiply across.
And then I multiply straight across. So I'm going to turn that into 1 over 1.
And 2 over 1, so then it's actually 2.
Exactly. And that's the power of changing decimals and working with the straight fraction. Because if I look at this from the fraction, I'm going, I don't know what to do with that. Do you know what I mean? Whereas if I convert it to the fraction, it becomes easier to deal with. I'm going to skip 0 for a second. Okay, I'm going to look at the 0.5. That's the same as this thing up here, only with a negative, yes?
So then it's the same thing, but
It's the exact same thing except with a negative. Write this anywhere you've got space or you need to. And you can add whatever words you need to add to make it make sense for yourself. Okay? So all we did was we convert this division into a multiplication. We took the denominator and wrote it as reciprocal. Then you multiply straight across. All right, looking at this, x equals -1.
negative one.
Yeah, our result is -1. X equals -2.
Negative 0.5.
Negative 0.5 or negative 1/2. And the -4?
Negative 0.5.
Negative 0.25 or negative 1/4. All right, notice I left a 0 blank. Good morning, it's Monday. All right, let's graph the points that we have so that we can figure out kind of what's happening at 0 because that's a special location in these graphs. All right, so we're going to graph at -4. Y is -4th. So it's like right about there. At -2, we're at -1/2. At -1, we're at -1. At 1/2, we are at 2. At 1, we're at 1. At 2, we're at 1/2. And at 4, we're at 0.25.
Oh, and we forgot negative 0.5.
Oh, you're right. I did forget -0.5 at 2. Thank you very much for catching up. All right. I'm going to connect those dots as smooth as I can. I'm going to use a pencil so that way it stays kind of light. If I were to continue these off to infinity, okay, let's look at the left side. If I were to continue this down, what does it feel like is going to happen?
It's gonna be
Remember, since it's a function, we want to try to connect them. Does it look like there's any way I'm going to be able to connect these things? Okay, let's explore for a second. We know what happens at -0.5. What do you think happens at -0.25? It's going to keep going further down. How much further down? I don't know. Let's play with that number, yeah? Let's figure that number out. Okay. So I'm asking the question, what happens at x equals -0.25? -0.25 is the same as -1/4. So my y is going to be 1 over that value of x. Take the top number and rewrite it. Take the fraction bar and turn it into a multiplication. Take the bottom and write the reciprocal. Now multiply straight across. I'm at -4. Okay? You all right so far with that? Okay. So at -1/4, I am down at -4. Now imagine something closer to 0. Like 1/10.
Oh, are we being that? Oh, we're getting this close, so we're not touching it.
Yeah.
Is this what we're doing?
Yeah, this feels like you'll get that sensation that I'm getting closer to 0, but I'm not actually going to touch it.
Wait, what you call it? You call it, don't be such a...
Asymptote.
Yeah,
Asymptote.
don't be such an asymptote. Can't touch that spot. Yeah. All right, so let's play with this for a second. Okay? So we're looking at a -1/10. We're playing that same game.
That way you don't want to do 0.
Are you okay if I write the reciprocal of 1/10 is just 10?
Yes,
Yeah? Okay.
because then it's the same thing across.
Yeah. So it's off my graph. It's way over here somewhere. All right, so we know what happens at negative a tenth. What do you think's gonna happen at negative 100?
It's gonna get like farther down.
Yeah, it's gonna keep more and more negatively infinity. But I never hit 0. So as I'm approaching 0 from this direction of the graph, I'm going to tend toward infinity without ever reaching 0.
So then 0 is not available.
So it doesn't look like 0 is available. All right, what about on this other side?
It'll be the same thing.
It's the same idea? Okay, well, what about here? Same idea? And over here?
Maybe with x in 1.
So our graph ends up looking something like this. And at 0, we have an undefined. It appears that in this kind of graph, we will never result in a 0, no matter what we put in for x. And it looks like if I try to stick x as 0, things break. I don't know what value to put. Okay? So what kinds of structures are we seeing in here? You had said something about an asymptote. Where is that asymptote? Where do they appear to be?
The x.
On the x-axis? Okay, so it looks like we've got some sort of asymptote happening right here. Horizontal or vertical?
Horizontal.
Oh goodness, that pen is shot. So this looks like it's some sort of horizontal asymptote. And what would its equation be?
Y equals 0.
This is telling us that we will never have 0 as the result for this function. I can stick any value of x in there I want. I'm never going to end up with a 0 as my final answer. Right? What else looks like it is some sort of asymptote?
The y-axis.
The y-axis looks like it's some sort of asymptote. Because again, we're approaching it, but we're never touching it. What kind of asymptote is this?
Vertical asymptote.
Okay. And what would be its equation?
X equals 0.
So not only will we never result in a 0, we're not going to be able to put 0 into the function. So 0 is locked out for both domain and range. That'll come back later. So this is our parent function. I'm going to write in the space for number 5. Let's describe this graph with some really great mathematical vocabulary. Words like asymptote. All right, describe this thing. Where does it appear?
In the first quadrant and the third quadrant.
First quadrant, third quadrant. Okay, so on number 5, we'll want to write something about the graph appears. The graph of f of x equals 1 over x appears in the first and third quadrants. All right. I wrote the graph of f of x equals 1 over x. I wrote this. Appears in the first and third quadrants. What else?
They both have asymptotes, vertical and horizontal.
Okay, this function has both vertical and horizontal asymptotes. Okay, this function has both vertical and horizontal asymptotes.
starts going negative. Never mind.
Okay. Should we talk a little bit about domain and range?
Isn't it?
It's just
All
gonna go on
real
infinitely.
Okay, it goes on infinitely. Range feeling like all real numbers, except which one?
0.
0. So the range is all numbers except for 0. Okay. The range is all real numbers except 0. What about its domain?
Same thing.
Same thing. The domain is all real numbers except 0. Not sure there's much more to describe on that. There's what I wrote. In case you missed any of the words, I'll leave that up for just a moment. How do you guys feel on doing these on your own, or do you want to see one more graphed? I've got 3 more that I can show you on this page.
How about 4?
How about number 4? Okay, so let's take a moment and let's do number 4 together. Thumbs up, I can move to number 4. Cool. All right, so I have -3 over x. So -3 over -6. This one is -3 over -3. This one's easy for me to do, that's 1. -3 over -1, that's easy for me to do, it's 3. -3 over -0.5, hard for me to do, I'm likely going to go to a sheet of paper. -3 over 0, this is my undefined spot. -3 over 0.5, that's going to be another one for my scratch paper. -3 over 1, that one's easy for me to do in my head. -3 over 3, also easy for me to do in my head. I think -3 over 6 I can do in my head. 1/2? -1/2, okay. Which means that top one is going to be a positive 1/2. Okay, so really I only have one thing that I need to do on a separate sheet of scratch paper. Yeah. It's 0.5?
No, I was saying.
Oh, the 0.5, yeah, the 0.5 is the one I need to do. Get some more scratch paper going on here. Alright, so I'm going to do this one. -3 over -0.5. That's the same as -3 over -1/2. Which is the same as -3 times -2 over 1. That's positive 6. Yes? Right, so this is 6. That makes this -6. And I only had to do one thing by hand. Oh, I'm so grateful for that. And when you're working with math, really, that's the trick, is to try to find what things are patterns so that you can do the least amount of work possible. Okay? All right, let's graph these things. At -6, we're at 1/2. At -3, we're at 1. At -1, we're at 3. At -1/2, we're at 6. At 0, we're undefined, so I have an asymptote. At 0.5, I have a negative 6. At 1, I have a negative 3. At 3, it's a negative 1. At 6, it's positive 1/2. So I have another asymptote thing happening right here. Ask a question about this. All right, you were welcome to grab yourself another sheet of paper, line paper, to do all of the fraction work. I'm going to highly recommend that you take that time to do this function work that I've been doing off to the side, okay? So that you can get comfortable dealing with those fractions and writing and thinking in fractions. Because really soon, we're in the section. We're gonna have to start playing with fractions that have a bunch of variables all over the place. Okay? And I don't want you to freak out with the fractions, so start practicing those now.